You know that feeling, right? You're thinking about a friend you haven't talked to in years, and then bam, your phone rings and it's them. Or you run into your old neighbor on vacation, halfway across the world. We call these moments coincidences, and they feel like magic, maybe even fate. But what if I told you they were, well, inevitable? Today, we're going to pull back the curtain and look at the surprising math that shows why these so-called miracles are not just possible, but actually, they're practically guaranteed to happen. Okay, so let's just kick things off with a story that sounds absolutely made up. This quote you're seeing is from Professor David Hand, a real-life expert on statistics. A novelist who he'd never met wrote a book about a coincidence expert who lived in the same town, whose wife had the same job as his, and who even shared his exact birthday. The wildest part, the author swore he had never even heard of Professor Hand. I mean, that seems impossible, doesn't it? Well, let's see what the numbers have to say. So what is really going on here? Is it some hidden cosmic force at play? You know, what the psychiatrist Carl Jung famously called synchronicity. Or can we explain these bizarre, super meaningful moments with the cold, hard logic of mathematics? To really get a handle on the math, we first have to look inside our own heads. Why are we so fascinated by coincidences in the first place? Well, it turns out our brains are literally built to hunt for them. There's a name for this tendency. It's called apophenia. And really, it's just our brain's deep-seated need to find patterns, even in total randomness. Think about seeing shapes in the clouds. It's an ancient survival trait that helps us make sense of the world, but it also makes us see profound meaning in events that are just pure chance. At our core, we're just pattern-seeking machines. And this pattern-seeking instinct, it leads us straight into one of the most common logical errors there is, the correlation trap. This is that classic mistake where we see two things happening together and our brain just leaps to the conclusion that one must be causing the other. Which brings us to what might be the single most important rule in all of statistics. Say it with me, correlation does not equal causation. Just because two things are trending in the same direction, it does not mean that one is responsible for the other. Sometimes, folks, a pattern is just a pattern. And here is a perfect and, let's be honest, kind of hilarious example of what's called a spurious correlation. There is a shockingly strong statistical link between the amount of cheese Americans eat and the number of people who die by getting tangled in their bed sheets. Now, obviously, cheese isn't causing this. It just makes a really important point. Without a real logical reason for a connection, a correlation is meaningless. So please, don't throw away your cheese. You know, big tech companies learned this the hard way. They'd see all these strong correlations in their user data, like maybe people who used a certain button were more engaged. But those are just observations. It wasn't until they ran controlled experiments where they could isolate that one single variable that they could actually prove cause and effect. Think of it this way. An observation is a clue, but a real experiment is what cracks the case. Okay, so if it's not magic and it's not some hidden cause and effect, what's left? Well, this is where we get to the core mathematical principle that really makes these miracles happen. It's a beautifully simple concept called the law of truly large numbers. All it says is that if you have enough opportunities, any outrageous 1-in-a-million long shot becomes not just possible, but actually likely. Just think about it for a second. With 8 billion people on Earth, a 1-in-a-million event happens 8,000 times every single day. This idea is captured so well by something called Littlewood's law. A mathematician named John Littlewood figured out that we experience about one event per second of our waking lives. Well, that adds up to roughly 1 million events every single month. So what does that mean? It means that a 1-in-a-million miracle should happen to each and every one of us, on average, about once a month. Wild, right? Professor David Hand, the guy from our first story, bundled all these ideas into what he calls the improbability principle. It's got a few parts. We've already talked about the first one, the law of truly large numbers. The second part is the law of near enough. This just means we're pretty flexible with what we count as a hit. Bumping into someone from your exact hometown is a crazy coincidence, but bumping into someone from the next town over, or your state, hey, close enough, we count that too. And finally, there's the law of inevitability. It's inevitable that someone is going to win the lottery. It only feels like a miracle when that someone happens to be you. Okay. Now for what might be the most famous, most mind-bending example of just how terrible our intuition is with probability, the birthday paradox. So I want you to take a second and really think about this. With 365 days in a year, how many people do you need to get in a room to have a 50-50 shot that at least two of them share a birthday? Now, your gut is probably telling you a big number, right? Like maybe half the days in the year, 180 people, something like that. The answer is just 23. That's it, 23 people. With only 23 people in a room, it is more likely than not that two of them share a birthday. I know, it feels completely wrong. It sounds like it can't be right, but the math is absolutely solid. And here's the key. Here's why our brains get this so wrong. We instinctively think about the odds of someone matching our birthday, but that's not the question. The question is about any two people matching. With 23 people, you're not making 22 comparisons. You're creating 253 unique pairs, 253 different chances for a match. The number of connections just explodes exponentially, which is why the probability skyrockets so fast. By the time you get to 57 people, a match is almost a dead certainty. So we've seen how our psychology and the laws of math can explain away a lot of what feels like magic. But this leads us to a final and honestly a much more profound idea. What if the math doesn't destroy the wonder? What if it actually reveals a deeper, more beautiful kind of order? This is the core idea of a field of math called Ramsey theory, and the bottom line is this. Complete and total chaos is impossible. In any system that's big enough, some kind of order is guaranteed to pop up. There's a famous example. In any group of 6 people, you are guaranteed to find either 3 people who all know each other or 3 people who are all complete strangers. No matter how you arrange the relationships, one of those patterns has to emerge. And this quote is just the perfect way to wrap things up. Understanding the math behind it all doesn't strip away the wonder. If anything, it reveals the elegant, awesome structure of reality itself. The real magic isn't that these strange things happen to us. The magic is that in a universe of truly large numbers and infinite connections, they are mathematically bound to happen. So the next time you experience one of those incredible coincidences, maybe the question to ask isn't why me? It's why not?